All right, hello again. This is Jeff Scott at Blackhawk Technical College, and I have been going over the PowerPoint presentations for our book, starting out with Java from Control Structures through Objects, 6th edition by Tony Gaddis for the 152-143 beginning Java programming class for the spring 2016 semester at Blackhawk Technical College. I've done the first 4 chapters, so now it's on to Chapter 5, which is on methods. So, as you can see here, we get an introduction to methods, talk about passing arguments to a method, more about local variables, how to return a value from a method, and problem solving with methods. You've already been working with methods, whether you realize it or not, because when you create a Java program, a Java application, every Java application must have at least a main method. All right. The problem is, as we go on in here, main has been getting bigger and bigger as we get more and more complex programming under our belts. So, methods, as mentioned right there, are oftentimes used to break down a problem into smaller, more bite-sized pieces. Sometimes called divide and conquer, sometimes called top-down methodology. It just depends on the book that you read. Methods really and truly do simplify programs. All right, it's a delegation of authority. So imagine for a second that I owned a company and I was selling widgets out of my garage. Okay, whatever the widgets happen to be. And I'm making a living, but not a great living. And I may be selling 100 here and 100 there. And all of a sudden I get an order for 100,000 from some company. And I can do it, but it's going to take all my time. So I've been making these widgets out of my garage, and now my garage isn't big enough to hold 100,000 widgets. So I buy a warehouse, or I rent a warehouse. That's probably more like it. And I rent this warehouse, but I'm still doing everything. In other words, I'm creating the widgets, I'm packaging the widgets, I'm delivering the widgets in the warehouse. I'm responsible for keeping the warehouse clean, cleaning the toilets, cleaning the offices, etc. Well, the chances are pretty good after a while that's going to be too much. So I'll start hiring other people and I'll start delegating authority. That's exactly what happens when you start using methods. You start to delegate authority. And that's exactly what we're talking about here. The other thing, too, as mentioned here on the bottom bullet, is methods also help to simplify programs. Because if you've got a task, so let's say that throughout a program, I was writing a Java program, and throughout that program, let's just suppose for a second that I was doing some kind of a sorting mechanism, and I was doing that sort many times during the program. Well, wouldn't it make more sense to write that program a sort routine once and then call it several times as opposed to writing it several times? It just wouldn't make any sense to do that. And as mentioned here, that's referred to as code reuse. All right? So far when we've been writing methods, we've had main, okay? And main doesn't return anything. It is a void method, okay? And actually, any method that doesn't return anything is a void method. So typically, or technically, as mentioned here, even system.out.println really and truly is a void method because it does its job and it doesn't return anything. All right? On the other hand, it says a value returning method not only performs a task, but it also sends a value back. So when I do this, this is taking the string 700 and parsing it or converting it into an integer and throwing it into an integer variable. And what that does is not only does that call a method, all right, so not only does it call a method, but it also takes the result, or it has something that returns back and puts it into a variable. So that's a value returning method. All right. So when you talk about creating a method, as it says, a method must have a definition, which consists of a header and a body. The header is at the top of the method. It lists things about the header, including the name of the method, what it returns, what its access specifier is. In other words, does it return nothing? Does it return an int, etc.? All right. The body is what goes in between the curly braces. Okay? So here's an example. So if we were to write our own little method here, and that method is called displayMessage. Let's just take a look. Let's break down the method. All right. It's public, meaning it can be called from within the class or from any other class. It's static, meaning there's just one of these. All right. We're going to get into static in a little bit more depth and breadth of coverage either in this chapter or the next chapter. It doesn't return anything. And it's called displayMessage, which is a pretty good name because that's what it does. It just displays a message. So that's the actual method. To call that method, we just say displayMessage, paren paren. And it's paren paren because it doesn't require any parameters here. So access specifier, all right, the fact that there's just one of them, static, returns nothing, name of method, parameters, there aren't any, but you need the parens. Inside of the curly braces is the body of the method. All right, and that's what they explain here. So as it says, with public, it's available to code outside of the class. Static, there's just one. It belongs to the class, not to an object. Return type, in this case, it's void, meaning it returns nothing. But we could return any kind of value, including, as we see as we go on in here, arrays or objects or whatever. But you can only return one thing from a method, just like you can only return one thing from a function. All right. Method name should be descriptive of what the method does. Parentheses either contain nothing or a list of one or more variable declarations. Again, that's how you call the method. All right, you can document methods, and you can document methods via the use of those Java doc comments. And I just wanted to mention to you, just so you see this, what I put out, I'm back at Blackhawk, so what I put out there, again, just so you see this, is if you go out to the P drive, if you want to learn more about this, and if you don't, you don't. But under the 152-143 for spring 2016, there now is an in-class folder, and the only thing that's in there is this document that's called Lab 4 Java Doc that I found years ago. And it's got Wile E. Coyote and the Roadrunner on it, but the point is it's got a simple Java program. But somewhere in here, they start talking about Java doc comments. And the author mentions that if you want to go and compile a Java program for Java doc, if you do it from the command line, this is the way that you can do it. And when you do it, you end up getting comments that look like this. In other words, the comments that you create get changed, so to speak. They get kind of a wrapper put around them, so they look more like the Java API comments. If I have time, I'll write a program and put some of these comments in there just so you can see what this stuff is like. Close this here. Okay. All right, you can pass arguments to a method, and you've done this already. Here's a couple of examples. Anytime you say system.out.print or printline and you put something in between the parentheses, that's an argument that's being passed to the printline method. Anytime you do an integer.parseInt, whatever you pass into that, that's an argument into the integer.parseInt method. So as it says, the data type of an argument in a call must correspond to the variable declaration of the parentheses. So in other words, system.out.println expects something to be in here. This expects typically a string to be put in there. All right. By using parameter variables in your method declarations, you can assign your own methods to accept data this way. Here's an example. So we're calling this very simple little routine that's called displayValue. It's public, it's static, it returns nothing, its name is displayValue, and an int gets passed in, which is referred to as num. This is called the formal parameter. When you call it up above, when you call displayValue, you're passing in the number 5. That number 5 is referred to as an actual parameter. So again, just so you hear the verbiage, actual parameter, formal parameter. And as you see, they don't have to be named the same thing. So this takes num, and 5 is what gets copied in there. So num now holds 5. So it says the value is 5. Pretty simple stuff. When you pass an argument to a method, be sure the data type is compatible. If it's not, so in this case, we tried to pass a double in where it was expecting an int. You'll get an error message. The compiler can't handle it. You can pass multiple orders in. Notice as they say here, the order matters. Now, what we're doing here is we're adding 5 plus 10. All right, so 5 goes in for num1, 10 goes in for num2. So 5 plus 10, it wouldn't matter even if we reverse these because 5 plus 10 is the same as 10 plus 5. But what if instead of adding, we were subtracting here? Now if we pass it in this way, it's going to be 5 minus 10 or negative 5. If we pass it in with the 10 first, then the 5, it's going to be 10 minus 5 or 5. So the order is going to matter. In Java, all 8 of those primitive data types, do you remember what the primitive data types were? There were 8 of them. All right, so our primitive data types, again, there's a byte, an int, a short, and a long. Those are all whole number data types. There is also a float and a double, and there's char, and there's Boolean. Those are our 8 types. All right, the author says there, all 8 of these, if you pass a variable of any of these types to a method, it gets passed by value, which means a copy is passed. So if you do change the value of the parameter in the method itself, you're changing a copy. So when you get back to the actual method that called that method, it has no effect on the original argument. All right? On the other hand, if you pass an object to a method, you pass the address. So anything that you pass, any change you make is a permanent change. A string, for example. If you pass a string to a method and you change the string in the method, it's a permanent change. So this is an example. All right. Show length name. And you're going to come in here and it's going to be called string. So let's say, as it says, the name. And then we go in here and we reset the actual string value to Joe. All right. It says when you do this, so they are assuming here the name was Warren. Okay. So up here when you pass name, it's passing in Warren. So it'll say Warren is, and WARREN, 6 characters long. But then you set string equal to Joe. So what happens is Warren is someplace in memory, but since strings are immutable, that place in memory can't be changed. So what happens is the place in memory that held the address, there's a different value in there. So in other words, let's say that at address 1000 there was Warren. So if we come in here and we say str equals Joe, now maybe at address 2000 there's Joe. And this is basically marked as being unused right now, or it's just garbage for lack of better words. So we've changed the value from Warren to Joe. Okay. All right. You can use different types of Java doc comments to add information in to your programs. This helps, as it says, in documentation. So param tags are used, and they must appear before the general description. But what you can put in there are the parameters that are passed in to a method. And again, what that does is it makes your method even more self-documenting. All right? All right. Remember that a local variable, by default, is declared inside of a method. So it's not directly accessible to statements outside of the method. Different methods can have different local variables with the same name because they're different variables. A method's variables only last while the method is executing. When the method ends, the local variables are destroyed and any values are lost. All right, local variables are not automatically initialized. But one way that you can send data from one method to another is to pass it. For instance, this is a simple example, but in here we're passing the string 700 into the parseInt method. And from there, we're going to return the number 700 because that's an int. So we parsed it or converted it into an integer. If we put in there hello, for example, we get an error message because we'd be trying to take a string that cannot be parsed into an integer, and we're trying to parse it into an integer. We'll talk about how to handle that kind of stuff next semester. So here's an example of defining a method that returns a value. So we're saying here that it's public and it's static. Its name is sum. There are two variables passed into it, and it returns an integer. This int right here must be the same as whatever type you're returning. They must be of the same data type or you're going to get an error. So we're passing in two numbers. Let's say again we passed in 5 and 10. All right, then we'd have int result. Result would equal 5 plus 10, so it would take 15, assign it to result, and then return. Technically, when you write this, just so you know too, you wouldn't have even had to have had int result. All right, this could have been done as one line of code, just so you know that. We could have said in here just return num1 plus num2. It would have done the same thing without the necessity of creating another variable, and it would have worked just fine. All right. So they're showing exactly what I just mentioned to you, but they're using 20 and 40 where I used 5 and 10. Okay. Not only can you have param or param tags for Java comments, you can have return tags to explain what something is returning. All right. Finally, you can return any type of value. In other words, you can return nothing, which is a void return type. You can return an int. You can return a float. You can return a double, a byte, a short, a long, a char, or a Boolean. Some of these are used more than others. You're more than likely will return like a double or an int or a Boolean probably than most of the rest of them. But here's an example. What you're doing is you're checking and you're saying if the number that you entered was between 1 and 100, all right, you're going to return true. Otherwise, you're going to return false. Again, it would have been totally legit in here to not even have a variable called status. You could have said if number greater than 1, greater than or equal to 1, and number less than or equal to 0, return true. Then you wouldn't have even needed an else. You could have just said return false. So in other words, I would have taken this. I would have taken what you have here if you wanted to really cut down on it a little bit size-wise and probably written it more like this. It's going to be a little big here, so let me make it a little smaller. All right, so you really wouldn't need this Boolean status variable. But then I'd write it like this. I'd say, okay, if this is the case, return true. Then I don't need any of the stuff that you see in here. In fact, all I need is just this. So that really kind of collapses the function down. All right. The other thing that I could do, is I could put that Boolean status variable in there and just set it to false. And if this is the case, then I could say status, oops, that should have a semicolon at the end. So status equal true, and then I could just come down here and say return status. So as you can see, there are a number of ways of doing this. And none is necessarily much better than the other, but I just want you to start getting the idea into your head that there's a lot of different ways of doing the same thing in here. You can return objects also. So here we're returning a string, which is John plus Martin, so it would return John Martin. Since it's a string, we have to say that our return type is string. All right? Okay, they end the chapter by saying that a large, complex program can be solved piece by piece using methods. Again, it's called stepwise refinement, functional decomposition, divide and conquer, a lot of different ways. They say here, if a method calls another method that has a throws clause, then the calling method should also have the same throws clause. You're going to see examples of that, and if there's time, we'll take a look at that particular example at the end of Chapter 5. And that's it for the chapter. So I'm going to come back in just a couple minutes and go over Chapter 6, which is our first look into classes.